Let's begin with making a concept, I think. For let's call it is graph data. I think we have an is derived from, no? No, is base class off, I think we have. Or do we have both? Is base class off, base off. If derived is derived from base, or is if both are the same non-union clause, provides true. Okay. Feels like what I need. So is base of base comma derived. That's the other way around I would do it. Realityscape, hello. What do you mean at this point? Yeah, just always stream. Is base off? Base derived? No. Graph data. Yes. That's what I do. Template, type name. Well, so we can now use this concept here. Let's call it graph data. Nah, it's a bit too much, right? Let's call it GD, graph data. Well, I don't think you should do anything that you don't like to do when it comes to computers anyway. So I made graph a template now, which is not going to work. Well, okay, I used to change this into graph base. That's what I did. Maybe it's not really base. It's maybe I should have another word here. What about just graph template? What's in a word, right? Graph. Or I just pass it on like that, and I make add graph also a template. Maybe that's what I should do. No man, way longer, way longer. I deleted my streams at some point. I deleted hundreds of streams. Let me see if I can quickly find when I started. No, I cannot. There's absolutely nothing to see anyway. I'm not writing a game, so I only have a few very simple test cases. Plus, I think it's in the description, right? I'm not working on the Vulkan engine right now. I even changed the title. It's now called Live C++ Coding. No, I have something like this. So there you go, that was the engine, or at least the test case. What do you think, man? Yep, add graph. So I make the other add graph also a template. That was the engine. The test case, you wanted to see it. I think that should work. So now I call this one, which then calls that one. So now I have to change add graph to accept a graph data instead of a graph. So I have to add my graph back, I think. Graph template. I'm just going to do using graph template graph data. It should work. Now this one takes graph data. Oh, that's cool. You'll probably get further than me. At least quicker. So I already have graph data now, right? So graph data, there we go. But now I don't have graph anymore, which is annoying. So instead of graph, I'm now having graph data here. And then we'll have to make that work. Yeah, Brex is back. I'm being distracted, Brex, by Realityscape. No, it is physics. I've always hated school, well, like middle school and high school. So when I had to choose what university subject I would do, I was so stupid to think that I could choose between one of those high school subjects, which is ridiculous. Plus, I knew you could do computer science and electronics because my dad was into computers and my friends were doing electronics. But since I always hated that, I didn't want to do anything that was a hobby of me. Because then I was afraid I would start to hate my hobby. And basically that's why I do physics. Because computers and electronics are my hobby. Or still are, I guess. That's a very good age to start. You must be good then. How can you be coding? You are coding since 10 years old? How can you be coding since 10 years old and then say that you're too lazy to learn C++? Well, a complete game is way too difficult for one person. I think. Well, I have to continue coding, damn it. Come on, coding is more important than my social life. So I'll have to ignore you guys. Oh, well, Python is also a good language to know. A bit less suited maybe for AAA games, but yeah. I'm going to try concentrating here. Graph data, add node. Wait a minute, yes, okay. So I'm adding here a graph data thing now. And I'm change that into graph data. Try in place. So graphs should now be able to store graph data. Which it doesn't. Equals graph item only has a default constructor. How did that work then? Oh, of course, the default constructor creates it. Brand new. Let's look at it again though. So this would create a new graph data. No, it doesn't make any sense. Yeah, the only other option is the logical one, where a graph is derived from graph item, which is the case. Ah, yeah, okay. So I'm just inserting here a copy of the base class. And now that's definitely not good enough anymore. Definitely not good enough. Or is it? Actually, maybe it is. Now I think about it. Yeah. Yeps. Okay, so yeah. I'm having now a graph data itself. No, I am having a reference to an object that is derived from graph data. And I want to store a graph item. I think I just have to add a constructor for to graph item. Well, this would create it. Okay, create a new data object. No, well, that's what it does. I think the trick is here that we still have the default constructed stuffs. So I'm having a graph item const reference. That makes just a copy of it. And now I want to do something like, I think I have a graph data here, graph item, and I'm passing the data object directly. I think it's just a data pointer. So now I can construct a graph item from a graph data pointer. Right. So I can do a try and place key, comma, graph data pointer. Except that I need a non-const pointer. Oh, there. I'm not going to play around with references. Let's use a pointer. So this add graph must accept a graph data pointer. No. Concept is graph data. It's not known there. Why not? Ooh, because they are being added here. Oh, I need a BV. Remember access into incomplete type graph. Yes, I was afraid of that. Yeah, now we get problems with the for declaration of graph again, I think. Might as well search for that immediately. There is no need for it. Graph data is defined though. For declared rather. It's base of graph data, yeah, but graph data is a template. No, it's not. Well, not here anyway. And it's not. Wait a minute. No, it's not. Okay, maybe that works. Unknown, I missed that one. Yeah, I do have a graph here. So I need a forward declaration before graph data after all. Okay, and a graph is that. I think I can even do that and like this. I mean, template. It's gonna be suckage. I need graph template for declaration. Which means that we need this concept already. Oh, Moha. Use of undeclared identifier data. That should be base. Sorry, data is a member, protected member of graph item. So it says it doesn't know data. I know, cool. Use of undeclared identifier data. Oh, that thing again. Yeah. Yeah, I started completely over today. Let's do that for everything. Boom, 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 boom. Error calling a private constructor of class. Why? Because I never told it that this is actually an implementation of graph data. Where did I copy this from? So add graph. be graph data, I think. Yes. Now I'm confused. Why would I use a T there? Because oh my, graph data itself is a template. And this class, oh, this class is not a template. Never mind. Yeah, then I might as well have used GD here again, I think. Concept if is graph data. Let's just use graph data. Why is this graph? Add graph. Oh, wait a minute. I messed up a little bit. Let's get it back here. Too many typos. Reference is a pointer. Yeah, okay. Graph data is a pointer. Totally true. Now matching member function we call to add graph. In instantiation of function template specialization, graph data add graph whatever. In instantiation, candidate function not viable, first argument would lose const qualifier. Correct. Why do I have a constant here? We have a const because that's how we call it. So in instantiation, I guess this one. Yeah, after all, graph is const. No, wait, data is const. No, graph is const. So this cannot be constant. Argument to add graph cannot be const. Graph data non-const That's definitely still const. Add graph item. Makes no sense whatsoever. Of course it can be const. Can it not be const? Why would it not be able to be const? Yeah. I don't know. No matching member function for call to add graph. Trying to add outer subgraph. Candidate function available, no known conversion from dot graph, aka graph template of graph data to graph data pointer. Oh, now I wanted to pass a pointer there. I don't think not. Candidate template ignored, deduce type, graph item, graph data of first parameter does not match adjusted type const graph, aka graph template, const graph template, graph data. These are the more difficult errors, aren't they? I think I want to call this, and it doesn't do that because the const has disappeared. So yeah, outer subgraph is probably const. And I was like, that should be possible. It's const because this is const. Yeah. Should it be const or not? I think it should be const. It's hard to reason, but my intuition says that it must be const. So I'm gonna use a const cast even, if necessary. Somewhere. This must be const. Really. So graph, that means that outer subgraph, which is a member of this class, is now considered const, right? And this const promises that we won't change the current class. We won't change this. So we won't change this. Therefore, this one is being passed as a const, whatever it is. A const graph. To the add graph of graph data, which is therefore add graph of graph data, right? Jump to that. That is this. Nope, not this one. That takes a pointer. I'm afraid I have to run ctex. Yeah, so this one must really take a const graph because that's what's going to be added. And then the problem is that if I call data on that graph, that will give me a const pointer. Because data is implemented as two things. And if you call it on a const object, you get a const reference. Well, we definitely need a non-const reference. Now, though, the question is it a bad thing to get a non-const reference in this case while the current object is const? I think it's kind of okay to get a non-const data as long as you don't change it. The only thing you want to do is increment the reference count. Might even be possible on a const object, now I think about it. Data is derived from graph data, graph item data, which is derived from AI ref count. So here it takes a const. The counter is immutable, so yeah, you can we should be able to just work with const things. In other words, this one, we're calling add graph here on a const thing. Do that again, graph data. I'm having too many add graphs. So. Outer subgraph is a graph, which is a graph template of graph data. I'm gonna change that, but okay. Yeah, really? it's a graph item of something that is derived from graph data. Yeah, so this is being called. This is something that is derived from graph data, graph template. Pretty sure this is correct. So we do this and it should compile. Or at least now we call here. No matching member function for call to add graph. It's time to comment a few things out. Oh. What the hell? Okay, so that compiles. I'm pretty sure we do call this though. So now this add graph gets a const reference. Is that this one? Yep, so that's the only comment thing that I have to comment out at the moment. Well, if then I just want to continue passing things as they are, then that's a const graph data pointer. Maybe it's even going to work still. So we make this const. And that then what is going wrong, because my graph data here is just can still get the dot item. So this is the only thing that's possibly a problem now. Let's see if it is a problem. Pretty sure it was a problem, right? It's a problem. So I can now say, oops. I could solve it with a const cast at this point, I think. Just checking. Yeah, that compiles. But I hate casts, so yeah, what's really going on here? Can we not construct it from a const graph data? So we're trying to do a try and place here on graphs, which means that we try to construct a graph item from a const graph data pointer. So this must just be const. And that might work because you can have an intrusive pointer. Oh, well, actually, See, that's a problem. This is, the data here is really a non-const pointer to the data. Otherwise I would have to add a const here or something like that. I don't think that this will compile. Nope. Yeah, see, if I make data const object, then it's this is const, and then even this becomes the same thing. It returns data, which is then a const object. So there's no difference anymore between the two. That might actually work. Yeah, a non-const L value reference to graph item cannot bind to a value of unrelated. Yeah, call it unrelated. Yeah, but I need this one to be a non-const. Oh. Now you see the problem here is that it is actually a must be non-const because we want to call these functions on it. But if I comment these out, then now it compiles. Still not. Deja vu. Same thing here. Add the const in the wrong place. Graph data gives me a graph file, whatever. Oh no, there's still yet another. No, it compiles. Right, so where did I comment everything out? Like I said, digraph-ish. Here's one that's commented out. Aha, that works. Right. Excuse me more. Okay, so this is always the case, but it might be that rank there is never called. So what I can do is set it anyway, assuming the default. Right, so now still have to do that. Oh, it looks it. I guess I'll put that on the page side for you. Exclude. Repo base is always set to the where the base of my Git repository. Doesn't seem to use anything else. So the next step then is to change outer subgraph to that other class. I think I made that, I called that rank there, I think. Graph. Begin with data. No, to derive some graph data, obviously. Anonymous using equals reindeer graph data. Aye. Tot rengdeer, ja. You get here is called. Oh, cool. Okay, so might as well test it right there, I guess. No, might be called more than once, so we have to really call this one back. Yeah, well, I have to admit, I'm not trying to teach anything. I'm just working. And I stream so people can see what I do. It became way more popular than I had ever thought. And I like streaming this way. But it's only very occasionally that I say something that was intended to teach people something. Most of the part I'm just typing, as it were. So I want every time set rank there is being called on the graph that we added out of subgraph 2. It will also call set rank there on the outer subgraph because it was added to it. Yeah. Therefore, this function is called, which is a virtual function that we now can override. Because I made this new class here for it. And now we need to get back in this object that owns the outer subgraph. So my outer subgraph needs an owner object, owner pointer actually. That would be the reindeer graph. Oh, we don't get there. Okay. Well, that is annoying. I have to set the owner then. Somehow I need to get the owner here so that it would be well, that is a template. That means that my reindeer graph data also must be a template. And then we can set pointer. I want to have a non-const pointer to the owner. And then we can call back the owner once we have that. To reindeer changed. Except, of course, that at this point we don't know what the indexed container set is, because it's defined here. So I need a forward declaration at this point. And then we can't use it yet. So that has to be defined later. Much later, but let me put it here so you can see what we are doing. So this is now a template class rangdir graph index set rangdir. Final must not be repeated here. And then you have to put that below the definition of index container set, which is the owner. AKA, I could put it here. Could put it here. Let's put it here. So now if this virtual function is called, we call rangdir changed on the owner, which is not existing yet. So we need to add a rangdir changed, which looks very much like this one. Just copy it. But that will only work when I actually have my owner pointer set. So I have to add to the top a, well, I guess public function set owner. And now I need to call that in initialize, I think. I feel I'm missing an add graph here. I'm just adding it in the subgraph, not the outer subgraph. Why not? Oh, it is being done here. Okay. Yeah. So at the moment that the add, wait a minute, this is difficult. Yeah. Add graph. I think somewhere, yeah, okay, this is a random object that we add. This is a random object. Random, it's an object that is defined after the graph is defined, the dot graph. So the dot namespace doesn't know anything about this class. Yet it has a template function that accepts, well, any object, basically, as long as that object has an add to graph. Sorry, yeah, has an add to graph function. This one. And then if at the moment you add it, it calls this member function with the graph that you are adding it to. And then you can add yourself, as it were. And what we want to do is add the outer subgraph. So we have an outer and an inner subgraph in this object. And we just want to add the outer subgraph to the actual graph that this object is being added to. And then the inner subgraph is added to the outer subgraph. However, at the moment that this is executed, it will say, okay, this graph, the real graph says, okay, you add a subgraph. Then I have to tell the subgraph what my rank there is. So at the moment that we call this, rank there will be called on the outer subgraph. And then we get here, eventually. So I must make sure that the owner is set before we call this function. And if we do that initialize, that would be good enough, right? Because there's no way that this function is going to be called before that was constructed. And it is the constructor that calls initialize. So I think the initialize is the right place to do that. Okay. So here in initialize, I must make sure that the owner is set. And the only thing that we have is a rank there graph, aka subgraph. And then I can call set owner. Well, let's keep it simple. This. But that is this class. Sorry, that is this one. And it doesn't have a set owner, obviously. It does, however, have a data member. And it's a data function member. So I could do outer subgraph data set owner. And then we get the rank there graph data object, and that has a set owner object. But I'm not allowed to call data. I'm stubbornly sticking to that. It's trying to protect the user, but I'm starting to doubt them, I must say. Anyway, that means that we need to make this a class then. That is derived from. And then I can give this the set owner function as well. Which then can call data, because data is protected and a member of graph template. And then we call set owner on that. So here we call set owner on the outer subgraph, that is this, which then passes on to the data, which sets it. And then when the rank there is changed, we call back rank there changed on the owner, and then we get back in this object, and we print, we get here, hopefully. If the compiles, it works. It doesn't compile. As soon as it compiles, it will work. Use of class template rank there graph data requires template arguments. I consider the type already. Oh, so this is a template of its own again. Use of undeclared identifier data. Imagine that you're new to C++ and you get stuck on that for 3 days. Error. Use of class template reindeer graph requires template arguments again. Index. Set owner is a private member of reindeer graph. Yeah. Just made everything private accidentally. Now it compiles, so now it works. All that is, it's going to print we get here with an exclamation mark this time. Yeah. How cool is that? In other words, now we get here. Now we can finally fix the attribute on the outer subgraph. Hey Brex, you know that I didn't eat breakfast yet. It's now 2:30. Well, you know, you're in the UK, and I'm asking for permission to make breakfast. Seriously, I should stop doing this. I'm gonna make breakfast as soon as this one works. Okay, so maybe in 10 minutes. Because there's only one thing left now, and that is fix the attribute depending on the previous and the current value of reindeer. And I can get that from the outer subgraph. That's why I kept this. Thank you. Yeah, this one. So I get the current reindeer. And then we have to figure out if it actually something changed. Let's call it vertical, top to bottom and stuff. Oh wait, old reindeer, whatever, dude. Outer subgraph does not exist here. This is, oh it does, sorry, yeah. As soon as I get my old rank there, I can already change it. So let's do that. So now I want to call... Oh, wait a minute. If I do that, it's gonna call my virtual function back. Nope, I have to do that from the virtual function, which means that I don't have my old rank there anymore at this point. So this function is being called set rank there. No. This one here, set rank there. I can wait with that. Okay, we wait with it. So I call the rank there changed all the time. It's just the old value. And then when we get back, I call the set rank there of the base class explicitly. So rank there graph is derived from dot graph data, right? So if you call it like this, then you will call the actual virtual function of the base class, and not anymore the virtual function through the virtual table. Otherwise we would get back here, and no, we don't want that, of course. Okay, so this changes the rank there then of this object and the inner graph as well. And so at this point it's still the old value. And then the new one is, I'm gonna call it even new because it wasn't set yet, and it's not the current rank there anyway. Right, okay, then here we have to update the rank there attribute. And I did add it before. And we have to do that in the case that it is vertical. So I'm just gonna do this again if it is vertical. Otherwise, I have to remove it. I don't know how, if I already support it. I don't think I do. So I have an add attribute and now I need a remove attribute. Now let's skip the whole remove it. I don't know, this is a shortcut. I might as well call attribute list and see if we have something there. Let me first look at attribute list, I guess. Has key, get value, has key, yeah. I don't think I have a remove here. No. So I have an add here. I'll just have to add a remove, I suppose. Yeah, bullshit. Just attribute. Okay. Does this work? I'm not even sure. I'll have to look it up, I think. When was the last time I deleted something from a set? There's an erase. It has to be the erase. Iterators key. You can do iterator. You can erase by key. That's cool. That takes a cons reference. Well, might as well make a cons reference here then. So attribute list now has a remove. And I'm just going to call attribute list instead of add attribute. And then I have to create an attribute with just a key. So I don't think that's even necessary, but okay. Attribute can be constructed from just a key. So that totally works. There, bang, it works. Now I can go eat. Yep, so the rank there was changed to LR, which then caused the rank is same to be removed from wherever. Yeah, here. And then of course, if you don't do this, if I don't do this, still looks the same. Because it's still LR. What the hell? I did not compile. Yeah, it's still the same, like I said. Whoops. So no rank there LR here anymore, and then the rank is same, is still there. And if I do even worse, worse. How do we do worse? There. I set it to LR. And I do everything, and then just before writing it out, I'm setting it to BT. Oh, now it still works. So now it's set to BT, and then it added the rank is same back. How cool is that? Oh, I think I've deserved my breakfast. I'll be back after breakfast because it's still way too early to not code.